Well, it's Wednesday and I'm in sunny California. I know, don't feel bad for me, so here I am. Anyway, today what we want to talk about is, it's called quadratic models. And so it's basically how to set up an equation to solve quadratic models. So, how to solve quadratic models. I know, oops, models. So it's story problems. I'm so sorry. It's the way it is. So let's think about it. Example 1. You're going to throw a ball in the air. Sure enough, it's going to go up, and then it's going to come back down. So it says h of t, so it's the height over time, negative 16t squared plus 48t plus 6. All right. So the first question says find the maximum height of the ball. All right. So it's a parabola. The maximum height would have to be at its vertex. And to make sure I find the vertex, I'm going to use that negative b over 2a. Well, so that's going to be a negative 48, that's negative b over 2 times negative 16, because that's a. Alright, so I've got 48 over 32. Let's see what that is. 48 out of 32, I get an answer of 1.5. So that's time. That's 1.5 seconds before it's all the way at the top of its flight. Okay, so that's the time, but we also want to know the maximum height. So that's just the time that it took to get to the height. To get the height, we're just going to plug it in. So we're going to go, all right, h of 1.5, or the height, with respect to its time, 1.5 is equal to, let's see, negative 16 times 1.5 squared plus 48 times 1.5 plus 6, because all I'm doing is plugging it in to my original equation. So I'm taking the 1.5 and plugging it in for t. So let's figure out what that is. Okay, I'm going to go negative 16 times, oops, negative 16 times 1.5 squared plus 48 times 1.5 plus 6, and I get an answer about 42. So 42 feet. Okay, so I get an answer of 42 feet high. Okay, and it is in terms of feet. Otherwise, it would be in terms of 9.8, but it is in terms of feet and seconds. All right. Second one, find the time when it hits the ground. So probably what I want to do is, if I can put on my calculator, I can probably get when it hits the ground. So I'm going to go back to trying to find the 0. So if I go to, first of all, my window. Okay, let's think it. Let's be smart about this. So it's going to be in the air from 0 to, well, for sure 1.5 seconds. Let's let it go for maybe 5 seconds. Plenty long enough. Hit the ground, so it's going to be at 0 feet, but I'll leave it at negative 10 so I get a little bit of room. But I know the maximum height is 42 feet, so maybe I'll change this to 50. So I'm just looking at my question. X represents the time. 0 to 5 seconds is plenty. The maximum for the y, that's the height. I know maximum height is 42, so let's put it to 50, okay? So there's my window, which should work for me, okay? Then y equals, clear that, and let's put in our equation. Negative 16t, or x squared, x represents t, plus 48t, or x represents the t, plus 6, okay? Let's graph it. Okay, there it goes up. Now this is not the path of the ball. This is time. This is the ball goes straight up, but this is the time that elapses as the ball goes up and comes back down, right? So again, that's not the path of the ball. The ball goes straight up, comes straight down, but this is the height of the ball over time. All right, so let's go to calculate the 0, because I need the zeros. When does it hit the ground? Well, it hits the ground at when the height is 0. So let's find out the 0. So to find out 0, let's go to second calculate 0. And left bound is going to be above it, if that makes sense, left of it. And then right bound is going to be below it. So let's go and get the cursor a little bit closer. It doesn't have to be perfect. Okay, there it is. It's above it, which is left of it. Enter. Go below it, which is going to be on the right-hand side. Enter. Guess. So I get about 3.12. So I get about t equals 3.12. All right. Now, domain and range. Well, let's use a little common sense. So the domain is the x value. right? So the domain is the x's, but in this case it's t, or time. Well, the ball is in the air from 0 to 3.12 seconds. That's the domain. It's in the air from 0 to 3.212 seconds. The range is like the y's, right? So the range in this case is the height. Well, let's think about this. It's going to have a height of 0 all the way up to 42 feet. That's its height. So the height is from 0 to 42 feet. That's my range. Okay. Now graph it. So I don't have to do a fancy job of graphing it, but I want to get a basic look of it. I already got it in the calculator. So let's see if I can do a little bit of a graph here and a little bit of a graph here. This axis is time and height, right? Time and height. Time is only going to go from like 3 seconds, so I'll probably go 1, 2, 3, of course times in terms of seconds. 4. Height, we have to go all the way to 42, so I'll probably go 10, 20, 30, and 40. So it starts at a height of 6. When it's 0, I know we're at 6, probably a 6-foot man. So we'll put a dot at 6. When time is 0, it's at 6. Then it's going to go all the way up to 42, but it's going to be at 1.5 seconds. It's at 42, so I'll put a dot up here at 42. That's the point 1.5 comma 42. And then it hits the ground again at about 3.1, so I'll put a dot here about 3.1. So I've got a point at where it starts at 6 feet. Its highest height, 1.5 seconds, 42 feet. And then it hits the ground after 3 seconds. So it just goes up, comes back down. Again, this is not the path of the ball. This is the height of it over time. Okay, so don't get confused. Not too bad. Okay, let's turn the page. All right, example 2. So a farmer wishes to create a rectangular field using 100 meters of fencing and the side of a barn for each side, okay? So first of all, let's draw a picture. So I'm going to draw a picture over here. Put my barn. This is my barn. I'll put some fencing, rectangular fence this way. There's my fence. So there's lots of different ways you can make this fence. Lots and lots of ways. You can make it 10, 10, and 80. You can make it 20, 20, and 60. There's the bell again. All sorts of combinations. What I do know is this. Let's call this side of the rectangle x, which of course would make that side also x. And if I take 100 meters of the fencing, then if I use x of it here and x of it here, then what's left over here is 100 minus 2x, all right? So think of it this way. If this is 20, 20, then that'd be 100 minus the 2 times 20. Whatever these two pieces are, there's pieces of the fencing that we take away that we don't use here. Okay? So now, what do we know about area? Area of a rectangle. Area of a rectangle is just length times width. So in this case, it's going to just be my x times my 100 minus 2x. So area is length times width. So let's go x times 100 minus 2x. All right. I'm going to go ahead and simplify this, and I'm going to call it a of x because it's a function. Area with respect to the width is equal to 100x minus 2x squared. All right, I'm getting somewhere. There's my function. Find a function to model the area of the fence as a function of its width. Okay, so if you really want to get fancy, we can go a of w. Wow, for area with respect to width instead of x, we can go 100w minus 2w squared. And then we can change our sides to w, and this to w. Okay. When we graph in the calculator, we'll have to obviously use x. Now, what are the dimensions to maximize the area? So maximize area. Well, let's think about it. If I did graph this, think about it this way. It is a parabola because of the x squared or the w squared. So if I did graph this, the maximum is the vertex. Hey, there's that vertex again, huh? So the maximum really is the vertex. It's not like the last problem where it really is the highest height. This one's like the greatest area. So to find the vertex, again, we'll use our negative b over 2a, which is our negative 100, over 2 times negative 2. So there's my b, and there's my a. A goes along with the x squared or the w squared, right? So it's 100 over 4, which is 25. Okay, so that means my w is 25. All right, let's put that back in. So if the width is 25, all right, that means if this side's 25 and this side's 25, that makes 50 of it. And 100 minus that 50 is 50. So my width is 25, my length would have to be 50 meters. Okay, the domain. Domain's a little bit weird. So what we have to do is go back to what we know about domain. Domain is the x's, but you got to think about the problem before you really do the domain. What does the x represent? Well, the x represents the width. So if I'm going to build this fence, the very smallest width I could make is up to 0. I'm not going to say 0. I'm going to say up to 0. So I'm going to say 0 is less than x. Not equal to, because if it actually equals 0, it wouldn't have a rectangle at all. But it could be a little bit bigger. It'd be a pretty silly looking fence, but you know, like this being hardly anything. And that'd make the length really long. But at the same time, the width could be as long as almost 50. I could use my whole 100 meters fencing and go 50, 50, and then the fence would be super narrow. So up to 50, but not equal to, because if it equals 50, I'd have 50, 50, and I wouldn't have a rectangle at all. Okay, so that is the domain of this function. You could build, so what it's saying is you could build a lot of different fences where the width would be anywhere between 0 and 50, and you can build all of these. Now what's the best fence to build? The width is 25 and the length is 50. Okay, homework today, there it is. Draw a picture, show your work, make sure you guys work together, all right? I will be back and see you on Monday.